So now we're going to look at the shell method. We looked at the disc in the washer method in the last section, and now we'll do shell. And shell is it's another way to find the volume, and sometimes it's going to be an easier integral to set up than a disc or a washer. A washer especially, sometimes it's easier to switch it and do a shell. Make sure you printed out your notes. Make sure you printed out those magic notes that I also linked. And again, I tried to put little screenshots of those notes in here so you see how to use them. All right, so let's look at this first one. Find the volume of the solid generated by revolving the region bounded by the graphs of x equals 0, x equals 3, y equals 0, and y equals x squared plus 1 about the y-axis. So I went ahead and graphed it for you. All right, so we can see here's our purple region. We're going to rotate it about that y-axis. Okay. All right, so the biggest difference in a disc and washer versus a shell is for disc and washer, we had to draw that slice. We had to draw it perpendicular to the axis of rotation. For a shell, you draw your slice parallel to the axis of rotation. So I'm going to draw a rectangle parallel to that y-axis. So I'm hitting the x-axis now, and I'm a dx. So that's an easier one for me to set up because these graphs were already solved, for y equals, and it was easy for me to do this. All right, so let's look at our formula. So I've got it right here. It's 2 pi integral a to b. How far, the height, and the thickness. Okay, we drew our slice. All right, let's fill in our formula. Since I'm a dx, I'm going to get a and b off the x-axis. So you can see those red points, I'm going from 0 to 3 on this one. All right, how far? It says it right here. How far will be a plane X or a plane Y? Right? And that's when you're spinning about the X or Y axis. And you want to match the dummy, so here we go. It's going to be an X. Right? And then the height or the length will be a graph if there's only one, or top minus bottom, or right minus left. But it's the top minus the bottom, it's just that blue graph, and the bottom would be 0. So the blue graph is the x squared plus 1, right? And then the thickness is the dummy. In your notes, I posted that screenshot where it talks about, what is how far, and it's just a plane x or a y whenever you're spinning about the x or y axis. Okay, it's going to change when you're spinning about any other line other than the x or y axis. You're going to have a different thing to put in for how far. All right, I can't integrate it on this screen. Let me carry it over to the next screen. So I've got volume is 2 pi integral 0 to 3. What we had? We had x, and we had x squared plus 1 dx. So all I would do is distribute that and integrate it. So I got 1/4 x to the 4th plus 1/2 x squared, and I'm going to evaluate that from 0 to 3 and multiply it by 2 pi at the end. I'll do this first one fully out like all the rest of them, and then I'll kind of start skipping some steps. All right, so I'm plugging in 3, and I'm plugging in 0, which is just going to go away because that's just going to be 0. So I get 2 pi. All right, 3 to the 4th is 81. So I get 81 over 4 plus, all right, 3 squared is 9. I get 9 over 2. So that's 2 pi times, let's see, that would be 81 over 4 plus, if I changed it and got a common denominator of a 4, that would be 18 over 4. So I get 2 pi times, what is that? 99 over 4, and then I can cancel out. 2 goes into 4 2 times, so I get 99 pi over 2. So the shell method was easier for me on that one because everything was already set up to use a dx instead of a dy. All right, find the volume of the solid generated by revolving the region bounded by the graphs of 2y equal x, and I just switched it to y equal 1/2 x so I could graph it, and you can see that in blue. Y equal 4, got that one in red, and x equal 1 in green. So I've got my purple region colored in, and this time I'm going to rotate it about the x-axis. All right, so let's draw our slice. Shell method, you draw parallel to that axis of rotation. So drawing parallel would be like this. If I stretched it out, I hit the y-axis. That's a dy. Okay. All right, I think I can fit this in. So this is going to be, all right, 2 pi. All right, I am a dy, so I'm getting the a and the b off the y-axis. All right. So if I look at them, I'm going from 1/2 to 4, and if you need to, figure out where that is, you can plug it in, set them equal, solve it, all that. So I'm going from 1/2 to 4. All right. If you're spinning, then it's how far. And if you're going about the x or y axis, that's a plain x or y. You match the dummy, so that's a y. All right, and then the graph is going to be here, and it's going to be a right minus a left, because I've got the rectangle going right minus left. So the right end, I can't put in, be careful that you don't put in that 1/2 x, because the dummy is a dy, only y's in there. So I've got, it would be 2y is the right end, right, minus the left end, which would just be a 1. Okay. So that's 2 pi integral from 1/2 to 4 of 2y squared minus y. So if I integrated it, add 1 to it, divide by the new power, I get 2/3 y cubed minus 1/2 y squared, and I want to go 1/2 to 4 and multiply that by 2 pi. So you can do that math out and plug that in. I got 833 pi over 12. Again, I'll post the actual math where I worked it out in your class so you can see that and check your answers. All right, last two. So the first two involved us rotating about the x or y axis, and so again we said how far, it's just plain x or plain y. So the last two, all right, and it just says just set up the integral, don't have to work it, but set up the integral needed to find the volume of the solid generated by revolving the region bounded by the graphs of y equals square root of x, y equals 0, and x equal 4 about the line x equal 4. So I screenshotted this from your magic notes, if you're not spinning about the x or y, so we'll see what to do when we get there. All right, let's draw our slice first. Let's figure out where I'm my axis of rotation. So I'm rotating about the line x equal 4. So that's that red line in there. Okay. Draw your slice parallel to that line, and it would look like this. So the axis that I hit is the x, so I'm the dx. Alright, so my volume equals 2 pi. Alright, I'm a dx for sure, so get your a and b off the x-axis, and I'm going from 0 to 4. Okay, now, it's how far next. Alright, so how far, and then I'm going to have the top minus bottom part. Okay, but how far, it says if your axis is positive, I wish I had a highlighter, how far will be either the axis minus x or the axis minus y. So I'm going to do that axis minus x. Right? So the axis I'm spinning around is 4. Okay. So I got 4 minus x. Right? And then my graph, if I did the top end of the graph, it would be top minus bottom. I'll scoot that down. It would be top minus bottom. But the top is just the blue, the square root of x minus the 0, which is the green, the bottom. I don't need that. It's not necessary. So it'll just be square root of x, and then it's a dx. All right. It's easier. All right. So let's get it all the way set up right before you integrate it. If you distributed that, you would get 4 square root of x minus x on the square root of x. But before you can integrate that, you want to switch it. All right. So it would be 4x to the 1/2. Right. And this is just x to the first times x to the 1/2. So when you're multiplying the same base, you add up your exponents. So you get x to the 3/2 if you add that together. And then you could integrate from there. I'll let you guys do that. Well, I have time. I'll do the integration part. All right, so if you add 1 to it, you get a new power of 3/2 divided. Oh, well. This one just said set it up. So never mind, that's all I needed, but that's what you do. You would start that part, and I was forgetting the directions just said set it up. So I don't have the answer out in front of me to tell you what it would be, but we just have to set it up. Okay. All right, and then the last one, just again set up. So I'll try to keep that in mind. Set up the integral needed to find the volume of the solid generated by revolving that same region. So we graphed it. And this time I am revolving about the line y equals -4. So I'm revolving about this line. All right, so draw parallel to that line. Now throws me into a dy. So 2 pi All right, dy. So get those values off the y-axis. I'm going from 0 to 2. All right, now, how far? And then it's going to be a right minus a left. And then the dummy is a dy. So let's fill that in. So I'm going to flip back to the screen right before it so you can see this. It says if the axis was negative, right here, I'm going to circle it in green. If the axis is negative, then you're going to do x minus the axis or y minus the axis, and you would match the dummy. So for this one, I'm a dy, so I'm going to do that y minus the axis. And the axis is a -4. And then I'm going to do the right end of the rectangle, which is 4, minus the left end. Be careful you don't stick in the square root of x. Okay, you got to solve it. So y squared would be x if you solved, if you squared both sides, times your dummy. Okay. So 2 pi integral 0 to 2 of y plus 4 times 4 minus y squared. Right, so we don't have to integrate it, but I want to get it to right before I would integrate it. So FOIL that out for me. You would get 4y minus y cubed plus 16 minus 4y squared. And then you could go from there. And if you had to get the answer, you know, add 1 to it, divide by new power, and then plug in. All right, make sure you try some of your homework problems.